All right, so here's something that it's kind of a detail on the conic sections thing regarding parabolas specifically. And this is something that I was kind of tinkering with in my head going through high school. I never really came to a fully satisfactory um, version of how to deal with this. So I'm not, I'm not saying that I have a new way to look at anything, but I feel like there's some aspects of the logic that are probably valid and probably n- not really components of conventional mathematics. So, take a look at, basic parabola. So you've got an equation for this guy that's like y is x squared, yeah? Okay, so here we have our y-axis, here we have our x-axis. Okay, there's our origin. Right, so 0 squared is nothing, 1 squared is 1, 2 squared is 4, 3 squared is 9. Right, what is negative? Negative 1 squared is positive 1, negative 2 squared is positive 4, negative 3 squared is positive 9. So it comes through, like that. You got your parabola, right? Well, what happens if we flip this into x equals y squared, right? Well, that ends up being the same as y equals the square root of x, right? So that's what's going to happen there, is basically we're just changing the relationship between x and y here. Okay. So what we're going to get now is we're going to get something like this, y, x, and it's going to go this way. Right? We just took this part and rotated it. But what happened to this part? What happened to down here? Why did we lose that? And now that we can actually work with these, why isn't there a part that goes like this? And then similarly, why isn't there a part that goes like this? And if this should be there, why isn't there this part? Particularly when we pair this with the hyperbole, which we know have two sides. And around an ellipse, there's going to be four of those, right? So like, say we've got just some random ellipse here, and like that's its major axis, that's its minor axis, like that. So we've got this rectangle. So we've got these lines that come through here. These are the asymptotes. I go like that. Just by fiddling around with the positives and negatives on the equation for this ellipse, we can get this parabola that goes here, and it's the other branch of it, or we can get this parabola, or this hyperbola here, right, and the other branch of it, right? So there's a whole bunch of pieces here. Why is there only one piece here? And now let's say we take this a little bit further and we consider, okay, so what are negatives, right? What does it mean to have a positive and a negative? Well, they're really, so here we've got, say, a number line. So that's positive, that's negative, right? So it's just the direction that you're traveling. For a lot of contexts, this is arbitrary. If it's arbitrary, then it shouldn't behave differently. They shouldn't behave differently, right? So if I have one guy looking this way, and another guy looking this way, right, this guy should be able to treat this as the positives and this as the negatives, and the other guy treats this as the positives and this as the negatives. So this guy should get a parabola out facing this way, where this guy gets a parabola facing out this way, which is what we're seeing. Like, it feels like that should be there. In certain contexts, that should be there, right? I don't know. There's a lot here that's intriguing, right? And certainly, within conventional mathematics, a lot of times you're going to get, so this will be imaginary, or like parts of this will be imaginary, right? Things like that, I understand. But I feel like there's a bigger picture here that we're not quite getting at. I don't know.